Okay, I'm just going to do question 2A. Have a look, please, if you give a damn. And what do you notice about the question straight up? Sorry?
That's 5 on each side. That's 5 on each side. Shouldn't it be 7 on each side?
Which means what? Which means what? Means the area on each side is the same, therefore we only have to work out one. Because then you're just going to double it. Okay? Now Henry, listen carefully to this. This 7 and these numbers are unrelated. What is the standard deviation? That's rhetorical. Standard deviation is a number that represents how spread out it is. So we could be talking about a survey of car engines, and this could be 1800 cc's will be the middle, and the standard deviation could be 7 cc's for all we care. So there is no relationship between these numbers at all. Okay? So just because this is, we're asking you to find the probability from 55 to 65, the fact that that's 5, difference from 60 to 65, and that's 7 doesn't make it wrong. That's the question. Okay? This is just an arbitrary number that represents the spread, and that's it. So what we've got to do now is we recognize that each of these areas, that area and this area, are exactly the same area because of the symmetry. Okay? So therefore, if we work out that area there, just this side, and double it, that'll be our answer. So now we need to create a z value. Z is the physical distance between the middle and there divided by 7. Okay, which is 5 over 7. Now, Connor, if we were doing it on this side for the hell of it, it's still 5, isn't it? Just because, so whichever way you look at the subtraction, the sign of it is irrelevant. Okay, so it's 5 from there to there, it's 5 from there to there, so it's 5 over 7. Now 5 over 7 as a decimal is point what? 7.714. And we use 3dp because our tables have 3dp. So if we look up 0.714 in the tables, 0.714 is 0.2624. And I would normally just 0.2624. I would normally just do this. 0.2624 is the area, therefore the answer to the question, which is what is the probability of being between 55 and 65. It's 2 lots of this, which is 8, 4, 2, 5, 0.5248, and that's it. And remember, we only have to do this correctly twice in the test to pass the section. Okay? So that is the first one, made easier by the fact that it was 55 to 65. Now what would happen if the question said, work out the area from 51 to 65? You'd have to work out both sides. But that would just be repeating what we've done with 5 over 7. If this was 51, then we would do this bit, 0.714, and we'd get our 0.2624. We'd get that. And then on this side, we would go, oh, it's 51 to 60, which is 9. So we'd go 9 over 7 is whatever the hell 9 over 7 is. And then we would look it up and we'd get a number, and then we'd just add them together. So as I say, this one is made easier by the fact that both sides are the same, therefore we only have to work out one and then double it. Rightio, let's look at 2b and 2c, the same question, just with different numbers. Remember, it's really important to sketch these, because if you sketch them, then, I mean, obviously the answer to this one is going to be about I don't know, 0.4 or something, maybe 0.3 something, who knows? But it's not going to be 0.6 or 0.7 or 0.8. It's obviously less than half, and this one's going to be smaller than this one. Okay, this one on the right-hand side here, because 68 is much further away from the 60 than the 58 is, then clearly this one is going to be smaller. And so sketching it's really important. So, first job is to work out Z value. Z value, because we're ignoring the negatives, is the distance between the two numbers divided by the standard deviation as a decimal to 3dp. What's 2/7? What's 2 divided by 7? Anyone with a calculator might.
0.286.
What did you say, Brad?
5.
Well, is it 5 or 6? There's only one right answer here. Yep. 2 divided by 7. 2857 is obviously 286. That's the way it is. 285 is no good to us. When it's 286, that's going to cause an error. So 0.286 in my tables here. 0.286 is 22 onto that, which is 0.1125. So that bit, 0.1125 off the tables. Correct, because the tables always give you the bit by the middle. We don't want the bit by the middle because our diagram says we want that bit, so we go 0.5, take away that. Therefore, our answer is 0.3375. What? 3875, you're quite right. So 0.3875 is straight subtraction, 0.5 take away 0.1125, 0.3875, and there it is, which is fantastic. Now, over here, the Z for this one is 8 over 7. And what's 8 over 7? 1.143, rounded to 3dp. So 1.143. 1.143 in our tables is 0.379 with a 6 on the end, 0.3735. Everything I write on the board is what I'd write on a piece of paper if, in fact, I was doing the test myself. In exactly this way. I would just label parts of my diagram with the numbers that are important. I wouldn't try to sort of write it out. I would just say that 0.3735 is there. Fantastic. That's not the answer, of course. The answer is 0.5 take away 0.3735, which in this case, 0.1265. So that is a repeat of the question. By the way, if the question said what proportion of people it gets more than 68, what would you say?
Percentage.
And what would be the percentage of that? 12.65 would be the answer. Okay, a percentage is a decimal with a decimal moved over 2 places. That's it. So if the question says proportion, work it out as normal and then move the decimal point over 2 places. That is pretty basic, or should be.